Welcome to the AI and GIS Frontier podcast. Let's get into today's topic.
Today, we are covering smart cities and urban AI. Cities around the world are integrating AI with GIS, IoT, and sensor networks to transform how they manage traffic, zoning, infrastructure, and public safety.
What does the integration of AI and GIS look like in urban planning today?
The emerging standard is a three-part framework combining GIS for spatial analysis, AI and machine learning for prediction and pattern recognition, and multi-criteria decision analysis for structured prioritization. GIS provides the spatial foundation through mapping and data layering. AI contributes predictive and adaptive modeling, and MCDA incorporates stakeholder priorities into the decision-making. Cities like Lisbon and Tempe, Arizona, are piloting AI-powered vision systems mounted on vehicles to automatically detect and map issues like graffiti, road damage, and infrastructure deterioration. That data flows directly into the city's GIS for maintenance prioritization.
How does this connect to environmental management within cities?
Urban green space management is a great example. Cities are using AI to analyze satellite imagery and street-level photos to inventory every tree, assess canopy health, and predict maintenance needs. The GIS layer connects that tree inventory to stormwater management, urban heat island modeling, and air quality analysis. For environmental professionals working in urban settings, this means your urban forestry data feeds directly into climate adaptation planning. A city can model how planting trees in specific locations will reduce heat island effects, improve air quality, and reduce stormwater runoff, all driven by AI analysis of spatial data.
The OECD published a framework on AI for smart cities. What were the key takeaways?
The OECD emphasizes that AI is a strategic enabler for processing the rapidly growing streams of urban data. Sensor networks, IoT devices, satellite imagery, administrative records, all feeding into AI analytics. The key challenges they identified are fragmented integration of AI tools into existing workflows, incomplete automation, and algorithmic bias. That last point is critical. If your training data for a predictive model overrepresents certain neighborhoods, the AI will underserve others. For GIS professionals, this means building fairness into your spatial analyses is not just an ethical nice-to-have. It is becoming a professional requirement.
What about the generative AI angle in urban planning?
Generative AI and foundation models are entering urban planning tools. Researchers have introduced a large flow model, specifically designed for urban digital twin systems, integrating generative AI with foundation models for sustainable smart city design. Practically, this means urban planners will be able to generate and evaluate design alternatives much faster. Instead of manually designing 3 options for a new neighborhood layout and running environmental impact simulations on each, the AI generates dozens of alternatives that meet specified constraints like minimum green space coverage, maximum impervious surface, and walkability targets, then ranks them by environmental performance. The GIS analyst validates and refines rather than creates from scratch.
What skills should GIS professionals develop for smart city work?
Real-time data integration is number 1. Smart city GIS is not about static maps. It is about live dashboards that update continuously. Learn to work with streaming data, sensor APIs, and real-time spatial databases. Second, 3-dimensional visualization and analysis. Smart city applications increasingly require 3-dimensional modeling of buildings, terrain, and infrastructure. Third, understand the basics of IoT architectures, how sensors, gateways, and cloud platforms connect, because you will need to integrate this data into your spatial workflows. And for environmental specialists specifically, learn about urban ecology metrics, heat island modeling, and stormwater analysis, because these are the environmental applications that smart cities invest in most.
Smart cities are clearly creating major demand for GIS professionals who can work with AI and real-time data.
Absolutely. And the nice thing is that the skills transfer. If you can build a real-time environmental monitoring dashboard for a city, you can build one for a forest management area or a watershed. The underlying spatial data engineering skills are the same.